My name is Jasmine Cudmore, and this is my presentation for Unit 5, Atoms, Bonds and Structure. In this presentation, I will be discussing the various ways metals bond, the different types of bonding, the structures of the bonds, the shapes of the molecules, the different types of forces between the molecules, how boiling and melting points are affected, and how samples should be stored, as well as if they are a solid, liquid or a gas. Metal bonds, various ways metals bond. For example, non-metal to metal bonds and non-metal to non-metal bonds. Non-metal to non-metal bonds. Non-metal to metal bonds are also known as ionic bonds. These are solid. The non-metal are stronger than the metal and they can get electrons easily from the metal. Two opposite ions attract one another and they form an ionic bond. They do not have a definite shape and they have a high melting and boiling point. Some examples of non-metal to metal bonds are sodium chloride and sulfuric acid. An ionic bond is a type of bond that's formed from the electrostatic connection between oppositely charged ions within a chemical compound. Non-metal to non-metal bonds. A non-metal to non-metal bond are also known as covalent bonds. These would be either a liquid or a gaseous at room temperature. The two non-metals have a similar electronegativity. Neither one of the atoms is strong enough to attract electrons from one another. To stabilize this, they need to share electrons from the outer molecular orbit. They do not have a definite shape and their melting and boiling point is low. Some examples of a non-metal to non-metal bond are methane and hydrochloric acid. Non-metal to non-metal bonds are characterized by sharing pairs of electrons between atoms and other covalent bonds. Electronegativity. How does this affect the different types of bonding, for example, non-polar covalent and polar covalent? Non-polar covalent bonds. These are created when atoms share electrons equally. This usually happens when two atoms have the same or similar electron affinity. The closer their electron affinity is, then the stronger the attraction. Polar covalent. In polar covalent bonds, the shared electrons are unevenly distributed between two atoms. This leads to the formation of partial negative and partial positive charges. Polar covalent bonds show characteristics of both covalent and ionic bonds. They have moderate solubility, a lower melting and boiling point, and some degree of electrical conductivity in solutions. The greater the electronegativity difference, the more polar the bond becomes. Types of bonding. How do physical properties of substances depend upon the type of bonding and structure? For example, metallic, simple covalent, giant covalent, and ionic. Metallic bonding. This only happens between metals. Metal atoms form a trellis of positive ions. The outer electrons form a sea of dispersed electrons. These can move freely throughout the structure. The metallic bond is a strong electrostatic connection. Simple covalent bonding. Simple covalent compounds are made up of individual molecules. They're held together by covalent bonds. They usually have low melting and boiling points. They are usually gases, soft solids, or liquids. A simple covalent bond has poor electrical conductivity. They don't conduct electricity because they have a lack of free ions or electrons. Giant covalent bonding. In comparison to simple covalent, giant covalent structures are made up of a large network of covalent bonds. They extend throughout the whole structure. A giant covalent has high melting and boiling points. They are usually hard and insoluble in most solvents. They have a variable electrical conductivity. They mostly do not conduct electricity, as all of the electrons are involved with bonding. Ionic bonding. Ionic bonds is when one atom, usually a metal, loses electrons to form positively charged ions. Another atom gains electrons to form negatively charged ions. Due to the electrostatic attraction between oppositely charged ions, it holds the bonds together. Ionic bonds have high boiling and melting points, and they are soluble in water. They conduct electricity when they're dissolved or molten. This is because of the free moving ions. Electron pair repulsion theory. How does this affect the shape of the molecule? For example, linear, trigonal planar, tetrahedral, and trigonal bipyramidal. Electron pair repulsion theory, otherwise known as VSEPR, is valence shell electron repulsion. This can predict the structure of a lot of polyatomic ions and molecules. The central atom is a non-metal. It can also work for a few structures where the central atom is a metal. VSEPR and the Lewis structure used together can predict the geometry of all atoms in a molecule. VSEPR theory. The main idea is that the pairs of electrons repel one another. These pairs of electrons are known as groups. Due to the electrons repelling one another using electrostatics, the most stable arrangement of the groups would be the one that minimises the repulsion. These groups are arranged around the central atom so that the geometry favours them to be as far apart as possible. Here are some examples. Linear. Groups around the central atom is 2, the predicted bond angle is 180 degrees, and an example of a linear bond is carbon dioxide, or CO2. Trigonal planar. Groups around the central atom are 3, the predicted bond angle is 120 degrees, and an example of a trigonal planar bond is boron trichloride, BCI3. Tetrahedral. Groups around the central atom is 4, the predicted bond angle was 109.5 degrees. An example of a tetrahedral bond is methane, or CH4. Trigonal bipyramidal. Groups around the central atom is 5, the predicted bond angles are 90 degrees and 120 degrees. An example of a trigonal bipyramidal bond is phosphorus pentafluoride, PF5. Ions and molecules. Is the substance a liquid, solid, or a gas at room temperature? How does this affect boiling and melting points? How should the sample be stored? And the different types of forces between molecules and ions. Is the substance a liquid, solid, or a gas at room temperature? Liquids. If the particles have enough energy to slightly overcome intermolecular interactions, then the particles can move around but also remain in contact. This describes the liquid form. In a liquid, the particles remain in close contact. This means they don't have a definite shape. Or volume. However, the particles can move around freely. They take the shape that is dictated by the container that they are in. Solids. The particles of a substance in a solid are in a fixed position. This is because there isn't enough thermal energy to overcome intermolecular interactions between the particles. Because of this, solids have a definite shape and volume. Most solids are hard, however some are soft like waxes. Gases. If the particles have enough energy to totally overcome intermolecular interactions, then the particles can separate from one another and move around randomly in the space. This describes the gas form. Like liquids, gases also have no definite shape. Unlike solids and liquids, gases do not have a definite volume either. Changing from a liquid into a gas significantly increases the volume. How does this affect boiling and melting points? Each substance has its own boiling and melting point. The stronger the forces between the particles, the higher the boiling and melting points are. The strength of force between the particles depends upon the particles that are involved. The forces between the ions in an ionic solid are stronger than the forces between molecules in hydrogen or water. This table shows some melting and boiling points of some substances. How should the samples be stored? Acids. Concentrated acids need to be safely stored inside a suitable cabinet. Smaller quantities of dilute acids can be stored on a bench, but they must be appropriately labelled. Acids, chlorides, and fuming acids need to be stored in ventilated cabinets. Alkalis. These must be stored separate to acids because additional mixing of these concentrated substances will create large quantities of fumes and heat. Flammable solvents. These need to be stored in a specialised flammable solvent cabinet. These cabinets need to be labelled clearly. They also need to be positioned away from doors and other means of escape from the lab. Chlorinated solvents. These should be stored in ventilated cabinets separately from flammable solvents. This is because they could have a violent reaction with some of the flammable solvents and chlorinated solvents. Solvent waste. These need to be kept in separate containers away from other solvents. The containers need to be clearly labelled. Noxious chemicals. These should be stored in ventilated cabinets. The fumes are extracted by forced ventilation. Oxidizers. These should be sourced separately from other materials. They should be in a metal or non-organic material cabinet. They should never be stored with any flammable solvents. Carcinogens and mutagens, class 1 and 2, and substances toxic to reproduction. These must be stored in a secure and locked cupboard. A list of contents need to be maintained, and these should only be accessed by authorised people only. The different types of forces between molecules and ions, intramolecular and intermolecular. Intermolecular forces. An ionic bond. This is created by a complete transfer of valence electrons between the atoms. It's a type of chemical bond that creates two oppositely charged ions. A covalent bond. This is created between atoms that have similar electronegativities. This is the affinity for electrons. This is because both have similar affinities for electrons and neither one of them wants to donate them. Because of this, they share the electrons. Metallic bonding. This is a type of covalent bond. This specifically happens between atoms of metals. The valence electrons are free to move around the lattice. These are 3 examples of intramolecular forces. Intermolecular forces. Dipole to dipole interactions. This force happens when the partially positively charged part of the molecule link with the partially negatively charged part of the neighbouring molecule. Hydrogen bonding. This is a special type of dipole-dipole interaction that happens specifically between a hydrogen atom that is bonded to an oxygen, fluorine, or nitrogen atom. This type of bonding is a relatively strong force of attraction between the molecules. London dispersion forces. Under the category of the van der Waals forces, these are the weakest types of intermolecular forces. They exist between all types of molecules. The more electrons a molecule has, then the stronger the London dispersion forces are. These are 3 examples of intermolecular forces. I hope you enjoyed watching my presentation, and these are some references I have used to find all the information needed. Thank you for watching.